Bittersweet memories is all that I'll be taking with me. And I will always be doing statistics homework. Let's do an example where we're looking at two means. And that's interesting because we've talked about how to analyze two means against each other. And we're going to test the stress put on pylons in an arena based off whether it's a football game or a concert. I mean, football games, people are chanting and stamping, whereas a concert, they're all in unison. Could there be a difference in how much stress they receive? So we can do this in two different ways when I get to my hypothesis test. Notice we have assumptions of normality and equal variances that will allow us to do an Anova test, and it should sound familiar to when we tested two means against each other, assuming that the variances were equal. So I want to go back to when we did the pooled hypothesis test and calculate a pooled standard deviation and then do my t-test. And I'm going to remember this. I've practiced this a lot in previous homeworks. So now let's move to Anova, and we want to compare how those results work with each other. The first thing we're going to need is an overall average. And then to get my SSG, I'm going to take each of these averages minus this overall average. And if you're really mathematically minded, you might be looking at how N1, X bar 1, and here's X bar 1. It seems logical that if you start putting these pieces together, it's going to simplify down to something. How similar would it be to that? Well, you can prove that to yourself. I want to look at the SSE. I was part way through filling this out and I was like, oh, this is really obvious how connected they are. That's because I forgot the square root right here. And I'm sure that if I was teaching this in class, people would be like, hey, what about the square root? Yeah, I was supposed to have that on there. Otherwise, you don't get the 2.38. But let's look at what this guy gives us, which is 216. What I'm hoping is you're starting to see some similarities between what's happening here, but it should still look all confusing like, oh no, which one's going to give us the better test? And because I left the square root on, these now look too similar, and I'm spoiling some of my fun because next I want to put these pieces in the Anova table. We had 40 data points, so 39, 38, here goes the 1. There's our sums of squares groups, there's our sums of squares error, and this guy was N1 plus N2 minus 2 because we had two groups. That sounds a little bit familiar. Let's divide these out so that we get our final F. Now we're ready to finish our hypothesis test. We have null being that the means are equal. The alternative, we actually could list out all the possibilities here. Mu1 not equaling mu2. That's the only one, so it's easy. Or we could use words like we were doing with the Anova test before. Not all the means are equal. Alpha 0.05. This time we have an F or a T, and we might want to look at which one gives us a better test. Here's some interesting things you might want to think about. That pooled proportion, if we square it, then what we have right here is a pooled variance, and that is the same number as the MSE. This MSE is the pooled variance, and you can probably see what was going to happen with the equations because I forgot the square root. But you take this, square root it, you get the pooled standard deviation. So do these guys have some similar connection? Like what if I took my t-score and squared it? And it works. We get t squared is the F. Now this worked because the degrees of freedom were 1. The F distribution is more versatile than what t can do, but if you take a t and square it, you get an F. Just like if you take a z and square it, what you get is called chi-squared. These have a connection and a relationship. So it probably won't surprise you when we go look at the applet. If I go to the t distribution with 38 degrees of freedom, input, and my t-score of 2.183, flip sides, 0.01764, I need to double that, gives me an answer 0.03528. And now on the F distribution, 1 and 38 degrees of freedom with the F score of 4.766, 0.0352, well, there's rounding 7, but they're the same p-value. Isn't that exciting? It's doing the same thing. Anova and the pooled test are the same. It's just that the Anova expands the pool test to more than two means. Now that we have our small p-value, we can reject the null and say that the stadium stress differs based on the venue. I ran out of room here to say based off whether it is a football game or a concert because I was running out of room on the board. But this should make you start to wonder, wow, what else can Anova handle that we already knew about?